This is lesson 14 of AS Pure Mathematics. Today's topic is exponentials and logarithms. An exponential is a function that increases or decreases rapidly and approaches positive or negative infinity. This is how they are expressed. E is a constant irrational number like pi. You don't need to know what it means, but it means that the gradient of the line at any point on the curve is equal to its x-coordinate on the graph. For logarithms, they are expressed like this, where a is the base, x is the answer if you were using indices, and y is the power. So logs are used to find x if it is the power in an equation. Similarly to indices, if the base of the log is the same as the answer, then it's 1, and if it's the log of 1, then it's 0. If you're working with e, then you'll need to use natural logs, which is just log to the base e. So the natural log of e to the power of a is just a. Same if it's e to the power of natural log of a. Now let's have a look at the rules for logarithms. If you add two logs with the same base, that is the same as multiplying the values in the log. You can see this in the proof if we set m to the log of m with base a and n to the log of y with base a. Next is that if you subtract two logs with the same base, that is the same as dividing the values within the log. And finally, if some value n is multiplied to a log, it is the same as a log with the same base, with its value to the power of that same value n. When solving an equation that needs to use logs, just look for if x is an exponent, which just means a power. Here is an example of how to solve a question like this. It's okay to leave it in this form as it's the exact form.